Chapter 15, problem number 10. In this case, we have a listing of 5 jobs. We're given the due dates and we're given the durations. So let's go to the software for chapter 15. And this only has one machine because it only has one column of time. So it's one machine sequencing. There are 5 jobs. They're alphabetical. So now we need to enter the information. So the time in this particular case is, they're in days, 8 days, 16 days, 40 days, 5 days, and 3 days. So you've got 72 days worth of work. But the order does matter. You're going to put in the due dates given to you in the question. One thing you're going to have to be careful of with this particular problem, or any of the other problems, is today is not day 0 or day 1. If you read the question carefully, it says it's currently day 275. So in this particular case, you have a starting date of day 275. So you need to make sure to enter that. Otherwise, all of your calculations will be incorrect. Now, in this particular case, let's analyze some of the numbers. Let's look at the average. Average flow time is 47.4. That means it takes on average 47.4 days from when a job arrives till it's out the door. And of course, you would like that number to be smaller. You can also see that there's quite a bit of lateness. The average job is late 14.8 days. So you're 15 days basically late on average. Some of them are quite bad at 32 and 29, but the average is almost 15. Your number of jobs currently in the system is 3.29. You would like that number to be lower because you don't want the jobs in the system. You want them out the door because once they're out the door, you can bill your customer. Your utilization rate of 30% is poor because you want a higher utilization. So that means you're only working on these jobs 30% of the time. So what if we were sequence them in a different way? So if we go to the earliest due date, we select the due date column and we sort it from smallest to largest, the soonest to the latest. You can see the numbers change. The average went way down. The average flow time went way down. The amount of lateness went from 14.8 to 4.2. Average number of jobs in the system also went down, which is actually good. And the utilization rate went from just over 30% to just over 41%. So that would be doing it using earliest due date. Shortest processing time, you select the time column and you sort it from smallest to largest. And once again, you see all that the numbers change. And you can see that you have the same amount of lateness, the flow time's less, the jobs are less, which is good, and utilization is almost 55% now. If you do the opposite for longest processing time, so take the largest job, so you go to the time column and sort it by largest, you can see, oh, we have a really bad situation. Now, I don't know about you, but at this point, I can't remember the numbers from shortest processing time, let alone from the very first one, which was first come, first serve. Fortunately, and I have presented this before, and students have told me they want me to show them how to do it individually. But as you may have noticed, there's a summary button up here, and I'm going to click on that, and you're going to see what happens. So, students have repeatedly told me they want to see how to do it individually and then click the summary button. I could have done that right off the start. But in this case, it does first come, first serve, shortest and longest processing times, earliest due date, slack, and critical ratio. So the average flow time, we want to have the smallest number. So SPT is the best. We want to have the smallest number of jobs in the system. So SPT is again the best. We want to have the highest utilization. So SPT is the best. Number of jobs late is a tie between SPT and earliest due date. And average lateness is a tie between SPT and average or earliest due date. So I wanted to show you individually how to do them. On your quiz or your assignment, you can just click the summary button, but you need to know what the numbers represent.